Hi everyone, this is James from GasGasGas. This video is about the Anrep Effect. This is an innate feature found in cardiac myocytes. And without further ado, let's get on with the video. Myocardial contractility, aka inotropy, goes up when afterload goes up. So, relevance from an anaesthetic perspective, giving someone metaraminol and maintaining a higher blood pressure would also lead to increased inotropy over time, because the time frame between this and this is about 10 to 15 minutes. And this is because changes have to occur within a cardiac myocyte that lead to improved contractility. Important things to note: there is no reflex arc involved, so it's not a reflex, it's an intrinsic property of cardiac myocytes. And this is demonstrated by the fact that the effect persists in a denervated heart, i.e. One that doesn't have any external autonomic nervous system involvement. So just to expand upon the physiology of the situation at hand and work through some of the physiological steps that demonstrate the Anrep effect. Originally identified probably by Anrep when he applied constriction to the aortas of dogs and noted a change in myocardial contractility. So, afterload increases. And just thinking about events in a human that might increase afterload, you could think about this in a aortic cross-clamping manner. That's chiefly going to be occurring in aortic aneurysm surgery. And that's an external clamp, but also RIBOA, used to some effect in lower limb catastrophic hemorrhage, but also used perioperatively when there's a high chance of hemorrhage. For example, prakrita surgery, where the placenta has invaded beyond the uterus and there's an exceedingly high chance of hemorrhage. But also you could imagine a little bit more left of field. So external tourniquets. Be that CAT tourniquet, so combat application tourniquets in the military, or perhaps your tourniquet for knee replacement surgery, etc. All would have an influence on afterload. I also wonder, although this is not evidence-based at all, whether or not standing on your head might increase your myocardial contractility because you'll have increased your afterload. I'm not going to go about and study that, but maybe it's something to think about. So we have an increase in afterload. This leads to an increase in end systolic volume. And this is because when you acutely increase the afterload, i.e. the systemic vascular resistance, the amount the myocardium can empty into the aorta goes down, because the amount of pressure the myocardium can exert against the afterload in relative terms is now less. So end systolic volume goes up. Increases end systolic volume, i.e. a fuller left ventricle, we'll just work off the left ventricle here, leads to more myocardial stretch. And this eventually leads to our increased inotropy contractility. Why? If you acutely increase afterload and there is no Anrep effect, your increase in systemic vascular resistance leads to a deterioration in your stroke volume and subsequently a drop in your cardiac output. So you can have a high pressure system subsequently with poor flow through it. This isn't optimal for organs to actually receive oxygen, nutrients and waste material to be removed. No good. Moving on. Another way you can help yourself to remember the Anrep effect is to try and imagine it as the Frank Starling effect occurring from the other end of the pump. So, Frank Starling mechanism, whereby increased preload leads to increased pre-systolic stretch of the myocardial muscle filaments, and this leads to an increased contractility. You're starting off with a state of more stretch with the Anrep effect because the heart hasn't been able to empty as readily, so it starts fuller before it then fills before systole. So there are apparently a number of physiological bases for why this occurs on a cellular level. One of these is the tension-dependent alterations in the sodium-hydrogen exchanger that is present on the membrane of the sarcoplasmic reticulum of a cardiac myocyte cell. So, step by step, this stretch subsequently leads to more sodium concentration in the sarcolemma This leads to impaired or modified sequestration of calcium into the sarcolemma, i.e. more calcium in the cardiac myocytes cytosol. As we all know, more calcium equals more contraction. And there you have it, Anrep effect, which is defined as the increase in contractility associated with an increase in systemic vascular resistance, or afterload, depending on the terminology you choose. Thanks for watching. If you enjoyed this, please consider subscribing to the channel. I'm going to continue to try and make videos initially based around physiology, and then we'll branch out into pharmacology and perhaps monitoring equipment associated with anaesthesia. Thank you very much, everyone.